All right, this video is going to be part 2 of proving identities, so let's go ahead and get started. I'm on number 1. It's cosecant squared minus cosine squared cosecant squared. And you want to prove that it equals 1. So here's how you would do this. The first thing would be to change cosecant to be like 1 over sine. It's like this. And like the cosine here is on top, but then change cosecant to be sine on bottom. So it's like this. And now you can use the first rule here. And when you combine this numerator, 1 minus cosine squared is sine squared. So it's really like sine squared over that sine squared, which is 1. And I would be done with that problem. Okay, number 2. Cosine squared plus tan squared cosine squared has to equal 1. All right, so I'd probably start here. I wouldn't touch cosine squared x. It's just cosine over 1. But then tan is sine over cosine. So tan squared is really like sine squared over cosine squared. That's just this part. So you still have times cosine squared, which is here on top. And so what's going to happen is these cosine squares are going to cancel. And so you're really going to have cosine squared plus sine squared, which is 1, which is what I wanted. So I would be done there. Okay, number 3. Secant squared plus tan squared secant squared has to be secant 4. All right, so the first thing I would do is I would change, like for example, I would change secant and cosecant and all those things to cosine. So that would look like this. 1 over cosine squared. Tan is sine squared over cosine squared, or tan squared is. And then you have this other secant squared, which is going to be another cosine squared on bottom. All right, so really it's like cosine 4 on bottom here. So to make these have a common denominator, you're going to need to hit this one on the left with the cosine squared over cosine squared. Because what that's going to do is it's going to make it cosine squared x over cosine 4x. And then plus this other fraction, sine squared over cosine 4. Now I could combine these numerators, and if you look at this, this is going to be the rule 1. So this just turns into 1 on top and cosine 4 on bottom. And then you can pull this cosine 4, this guy, you can pull him to the top and just call it secant 4, which is what I wanted. So I would be done there. All right, moving right along. Number 4. Got cotan squared cosecant squared minus cotan squared. All right, so the first thing I would do is I would change these, like cotangent squared is cosine squared over sine squared. And then cosecant here is going to be sine squared on bottom. And that's minus cotan squared, which again is cosine squared over sine squared. So this is kind of a similar scenario. You're going to want to have a common denominator. So like this one's sine 4. You got to make this one say sine 4. So I'm going to hit this one on the right with the sine squared over sine squared. That's going to turn it into this cosine squared over sine 4 minus cosine squared sine squared over sine 4. All right, so now you're here and you can combine the numerators. So it's going to be like cosine squared minus cosine squared sine squared all over that sine 4. You can GCF on top here. You can GCF a cosine squared out. It's going to leave 1 minus sine squared. And it's all over that sine 4. Now this part right here is rule 1. 1 minus sine squared is cosine squared. So the green cosine squared didn't change. This part becomes cosine squared. And it's all over that sine 4. So it's really like you have cosine 4 over sine 4, which is cotan 4, which is what they wanted. And by the way, you don't necessarily have to do it this exact way. This is just the way I chose to do it. So that would be how you do number 4. All right, number 5. All right, number 5 is a little trickier. This is where we really start to get more difficult. Cosine 4 minus sine 4. All right, the first thing I would do is I'd realize that this is really like cosine squared, cosine squared. That makes cosine 4. And then I'm going to do it to the sines as well. So it's going to be like sine squared, like this. And now the reason that I would do this is because now, I know this is going to look weird, but I can change cosine squared using rule 1 to be 1 minus sine squared. Like that. I'm not going to touch the other cosine squared. Still a minus in the middle. And now I'm going to do it again for this sine squared part. I'm going to call it 1 minus cosine squared. And then you still have your other sine squared. So that's really my first main move. And so now what you're going to want to do is you're going to want to distribute these guys. So it'd be like this. It'd be cosine squared minus cosine squared sine squared. Okay. Then it's a minus in the middle that I haven't messed with yet. Then it's going to be a sine squared minus cosine squared sine squared. All I did was redistribute there. Now, what's going to happen is why you wanted to do this is because you have a minus cosine squared sine squared, and then you have a minus negative, which is going to turn into a plus, really. So like I'm going to change this to like a plus negative sine squared plus cosine squared sine squared. You can make that change. And so orange with orange is going to cancel. And it's going to leave you with cosine squared minus sine squared. And so once you get here, you need to use that rule number 1 again and change cosine squared to be 1 minus sine squared. So it looks like this, and that's 1 minus 2 sine squared, which is what they wanted. That was a hard problem, I know. You really just have to be able to see like this stuff without it being there. I know it's difficult. Let's keep moving. Number 6. Secant 4 minus tangent 4. So secant 4 minus tangent 4. All right, change these to be like cosines and sines. So it'd be like 1 over cosine 4 minus sine 4 over cosine 4. All right, now these have a common denominator, so you can go ahead and combine the numerators. So it'd be like 1 minus sine 4 over cosine 4. Okay, this right here is a difference of squares. It is 1 plus sine squared, 1 minus sine squared. And it's still all over that cosine 4. So I just changed that difference of squares right there. All right, now this 1 minus sine squared is rule number 1. It is cosine squared. So my first 1 plus sine squared did not change. This becomes cosine squared. And then it's all over that cosine 4. All right, so now that you're here, you can cancel this and 2 of these cosines. So it becomes cosine squared x on the bottom. Let me just rewrite that to keep it clean. 1 plus sine 4 over cosine squared now. Sorry, it's a sine 2, not sine 4. Like that. Okay, and then once you get here, you need to break this fraction into 2 fractions. So like 1 over cosine squared plus sine squared over cosine squared. All right, the reason you want to do this is because now you can call this right here secant squared, and you can call this right here tangent squared, and then you can use your rule, the middle rule, to change secant squared to be 1 plus tangent squared. So you have 1 plus tan squared plus tan squared, which is 1 plus 2 tan squared, which is what they wanted. So I would be done. That was another pretty difficult one. They only get more and more difficult. So just keep that in mind. Let's keep moving. On number 7. All right, we got 1 over sine cosine minus cosine over sine. All right, so if I was approaching this one, the first thing that I would probably try to do is I would probably try to get common denominators. So in order to get a common denominator, this fraction right here needs a cosine. So I'd hit this guy on the right with the cosine over cosine. And I'd rewrite the problem 1 over that sine cosine minus cosine squared over that sine cosine. And you do this because now you can combine these numerators and you have 1 minus cosine squared, which is rule 1, that's sine squared over that sine cosine. And you do this because now one of these sines can cancel and you'll be left with sine over cosine, which is tan, which is what I wanted. And I would be done. All right, number 8. First of all, write it out. Let's see, we got secant over sine minus sine over cosine. Okay, first thing I would do is I would change secant. I'd call it cosine on the bottom of the fraction, so it would look like this. It would still be like a 1 on top and a sine on bottom, but now it would be a cosine on bottom. All right, the next thing I would do is I would get a common denominator. So this guy has sine and cosine. So this fraction on the right needs a sine on bottom. So I'd hit it with a sine over sine. And so I'd rewrite it 1 over sine cosine minus, now it's sine squared on top, and it's sine cosine. All right, and the reason you want to do this is because now you can combine these numerators. So I have 1 minus sine squared over that sine cosine. Well, 1 minus sine squared is that first rule. That's cosine squared, this right here. So this is going to become cosine squared on top over that sine cosine. And then now you should be looking to cancel one of these cosines. And so you're left with cosine over sine, which is cotan, which is what I wanted. So I'd be done with that problem. Okay. Number 9. I've got sine over cosecant plus cosine over secant. And I need to prove that this equals 1. All right, so the first thing I would do is I would be changing the cosecant and the secant. I'd be bringing them to the top of the fraction. So like sine is still there, but now cosecant comes to the top of the fraction and becomes sine as well. And then same thing over here. The cosine doesn't change, but now secant comes to the top of the fraction and is cosine. And so really it's like you have sine squared plus cosine squared, which is rule 1. That's just equal to 1. So I'd be done there. Okay. The next one is number 10. So I've got 1 over secant squared plus 1 over cosecant squared. I have to make this equal 1. Same thing. I'd be taking this, bringing it to the top and calling it cosine, for example. So secant squared comes to the top and becomes cosine squared. Cosecant squared comes to the top and becomes sine squared. And then it's just rule 1. Cosine squared plus sine squared equals to 1. So I'd be done here. That was an easy one. Which brings us to number 11. All right, number 11 is weird because, I'll just show you, hold on. This right here is a problem for you. What you're going to want to do is you're going to want to hit this fraction with the conjugate of that. So this is what I'm talking about. And the reason you want to do this is because now on bottom here, this is a difference of squares. So on top, it's just going to be 1 minus cosine x. That's easy. On bottom, it's a difference of squares that if you do it correctly, you'll get 1 minus cosine squared x. All right, so once you're here, the top doesn't change. But on bottom, that's rule number 1. So you can call this sine squared x. And why you want to do this is because now you're going to break this fraction apart. And so you're going to have 1 over sine squared. Then you're going to have minus cosine. Oops, not cosine squared, just cosine over sine squared. So this first guy is cosecant squared. The second guy, you should be thinking of sine squared as like 2 sines, right? And the reason that's important is because this right here is cotan, and this guy right here, who's still on the bottom of the fraction, so it's like 1 over sine, is cosecant. So you're left with this, which is the same thing that you're looking for. It doesn't matter the order of the cotan, cosecant. it could be written either way. So I would be done there. All right, number 12. This is going to be another conjugate situation. So it looks like this, 1 over 1 minus sine. You're going to immediately have to hit it with the conjugate, which would be 1 plus sine. So on top, it's just 1 plus sine. On bottom, it's a difference of squares. So that's going to be 1 minus sine squared. The reason you do this is because now you can change the bottom using the first equation here. You can call this cosine, cosine squared. So really I have 1 plus sine over cosine squared. And so now you break apart this fraction. So it's like 1 over cosine squared plus sine over cosine squared. And this 1 over cosine squared is secant squared. And if you think about this part, the sine over cosine squared is really like 2 cosines. The reason you want to think about it as 2 cosines is because you can group this sine in one of them. Sine over cosine is tan. And then you've also got this other cosine on bottom, so it's like 1 over cosine, which is secant. And that's what they wanted, secant squared plus secant tan, secant squared plus secant tan. So I'd be done with that problem. Okay, next up, number 13. We've got cosine over secant minus 1. And it's minus cosine over tan squared. Okay. All right, to me, what's jumping out is this secant x minus 1. This is basically the same scenario that we just had. So when we did conjugates. So I would immediately hit this with its conjugate, which is secant x plus 1, like this. So when you do this on top, you're going to have to distribute a cosine to both these things. Well, cosine times secant cancels and just leaves 1. And then you've got cosine times 1, which is plus cosine. And on bottom, it makes a difference of squares. So secant squared minus 1. And I haven't touched the fraction on the right. And I haven't touched the fraction on the right because secant squared minus 1, if you rearranged it, it is tan squared. So I could basically think of this as tan squared. And now they have common denominators. And so I can combine these numerators. Don't forget there was a minus there. I kind of covered it up like that. So you have a 1 plus cosine minus cosine. That's just going to be 1 on top. And on bottom, it's just tan squared. And so you can bring this to the top and call it cotan squared on top, like over 1 kind of, which is what they wanted. And I would be done with that problem. That was a hard problem just because of this right here. You had to know to do the conjugate. Okay, let's keep moving. Okay, I messed up my equations. There we go. All right, number 14. So when I look at number 14, I'm thinking conjugate and I'm thinking common denominators. So you got sine over 1 minus cosine. And it's a plus, and you got 1 minus cosine over sine. Okay, now, if I was doing this problem, I would be thinking to myself, on the left, I'm trying to get a common denominator here. So on the left, I need sine. And on the right, I would need 1 minus cosine. And I would be kind of multiplying this out. So here's what it would look like. I'd have sine squared over sine minus sine cosine. Then it's a plus in the middle. And then over here, you're foiling that out. You're going to get 1 minus 2 cosine plus cosine squared. And it's over that same common denominator, sine minus sine cosine. Let me clean that up. Okay, now you can combine these numerators. So when I look at it, I think to myself, I have sine squared plus cosine squared. That just makes 1. Then I've got this other 1. Then I've got my minus 2 cosine. And it's over sine minus sine cosine. I'm starting to think I should not have multiplied that denominator out, but let's just keep moving. Okay, 1 plus 1 makes 2. So 2 minus 2 cosine over, I'm going to go back. I'm not going to multiply those denominators out. Sorry for the confusion. Here's my denominator. I was writing it multiplied out. I'm not going to do that anymore. So I'm just going to call it sine 1 minus cosine. Okay, and the reason I'm going to do this is because up here, I'm going to GCF a 2 out. And so it's going to be 1 minus cosine x. And on bottom, it's sine 1 minus cosine. And so now these will cancel, and you'll end up with 2 over sine x. And you can bring that to the top and call it cosecant. So I end up with 2 cosecant x, which is what I wanted. So I'd be done. Okay, number 15. If you're still watching this video after all this time, I'm impressed. Okay, 15. You got secant over secant minus tan. All right, the first thing I would do is you kind of got to know this is going to be a conjugate. So I would be multiplying this by secant plus tan. So when you do this, up top, it's going to distribute. So it's going to be secant squared. It's going to be plus secant tan. And on bottom, it's a difference of squares. So it's going to be secant squared minus tan squared. All right. Look at these rules. Secant squared minus tan squared is 1. So on bottom, this all goes away, and it just becomes a 1 on bottom. So you don't even have to think about the bottom of this equation. You're really only thinking about the top. And on top, all they wanted was secant squared plus secant tan. That's what I have. So I'm done. Just by realizing that that bottom made 1 using this middle rule. All right, let's keep moving. Number 16, we've got sine cubed, cosine squared. And we have to manipulate this. So if I was approaching this problem, I would probably look at what they want. They want sine cubed minus sine 5, meaning there's no cosines at all. So I'd probably take this and I'd use rule 1 and I'd change it. So sine cubed x would not change. But cosine squared, you could rewrite it as 1 minus sine squared. And the reason I want to do that is because now I could distribute this and get sine cubed minus sine 5, which is what they wanted. So I'd be done. Okay, 17. Got sine cubed cosine squared again. Sine cubed cosine squared. And I need to get it to a bunch of cosines and sines. So the thing that I was thinking about last time, just changing cosine and being done with it, that's not necessarily going to work in this scenario. So here's what you need to do on this one. You're going to need to take sine 3 and realize it's 3 sines. Or realize it's 2 sines and 1 sine, like this. So cosine squared is still sitting here. Cosine squared still there. And the reason you want to do this is because now you're going to change sine squared using this first equation. This is going to become 1 minus cosine squared. And it's times that sine x cosine squared x. All right, and then you're going to want to redistribute this guy. So you're going to get sine x cosine squared, and then minus sine x cosine 4. And that's what they wanted. So I'd be done. Okay, number 18. We've got secant squared plus cosecant squared. All right, so I'd probably approach this one by changing these to cosine and sine. So first one is 1 over cosine squared. Second one's 1 over sine squared. Then I'd think to myself, okay, I probably need to get a common denominator. So the one on the left needs a sine squared. The one on the right needs a cosine squared. So when you rewrite it, it's going to be sine squared over sine squared cosine squared plus cosine squared over sine squared cosine squared. And now I can combine these numerators, and this is rule 1. And so the top's just going to make 1, and it's over that sine squared cosine squared. And from here, I'd realize that I can bring sine squared up to the top as long as I call it cosecant squared. And I can bring cosine squared up to the top as long as I call it secant squared. And this is what they wanted, so I would be done. All right, number 19. I've got secant plus tangent. Okay, this one's going to be weird. So the first thing I would do is I'd realize that it's like 1 over cosine plus sine over cosine, which means I can combine the numerators. So 1 plus sine over cosine. And if you get here, you're probably going to get kind of stuck. You're going to have to hit this with the conjugate of 1 plus sine, which is 1 minus sine. So on top, it's the difference of squares, so it's going to be 1 minus sine squared. On bottom, I'm just going to leave it without multiplying it out, so it's cosine times 1 minus sine. All right, up top, that 1 minus sine squared, that's rule 1. That turns into cosine squared. So it's really like cosine squared over cosine, 1 minus sine. One of these cosines will cancel, And so it's really like cosine over 1 minus sine. All right, so from here, what you're going to want to do, all right, this is the weird part. You can take a fraction and you can flip it. So like 1 minus sine over cosine, as long as you put a 1 over everything. Because if you think about it, this is like 1 over 1 over this stuff, right? And so normal fractions, you could have taken this and flipped it and multiplied, and then you'd be back to your cosine over 1 minus sine, exactly where you were. So writing it like this does not change anything, technically. Now, I'm going to take this bottom fraction, and I'm going to break it up. So like 1 over cosine and negative sine over cosine. So the 1 over cosine portion, that's secant. So it's 1 over cosine is secant. And then this negative sine over cosine, that's minus tangent. That's what they wanted. If that didn't make sense, I'm sorry. That was a really weird scenario, and you would have had to have known to do this flip here. So we'd be done with that problem. I'm moving on. Which brings us to number 20. Okay, this is number 20. And when you look at this problem, you should probably be thinking about a quadratic. Like, for example, what if it said 1 minus 3x minus 4x squared or something? You should probably be able to factor that like a trinomial. So if you factor this like a trinomial, you're going to get 1 minus 4 cosine and 1 plus 1 cosine. That's over sine squared x. Okay, now this bottom part, sine squared, I'd be changing this. Using rule 1, I can change this to be 1 minus cosine squared, which is a difference of squares. So my top hasn't changed yet. But the bottom, you can also factor this. It's a difference of squares. 1 plus cosine, 1 minus cosine. The reason you want to factor that is because now these guys cancel, and you're left with 1 minus 4 over 1 minus 4 cosine over 1 minus cosine, which is what they wanted, and I would be done. Okay, let's move on. 21. All right, this is 21. If I was approaching this problem, I would look at my answer. I have to get it to everything tan, which means these secants, they got to go. And so I'd be using rule 2. And so I would change secant squared, this right here, I would change it to 1 plus tan squared right from the start. And then same thing on bottom. I would change it to be 1 plus tan squared. So you can kind of combine like terms here. On top, you'll have tan squared plus, sorry, it's a minus 6 tan plus 8. I'm combining that plus 7 plus 1. And it's over tan squared minus 4, combining that minus 5 plus 1. All right, and the reason you want to write it like this is because now this is factorable, and so is this. The top's a trinomial that'll factor into tan minus 4, tan minus 2. The bottom is a difference of squares that'll be tan plus 2, tan minus 2. These tan x minus 2's will cancel. And it'll leave you with tan x minus 4 over tan x plus 2, which is what I wanted. So I'd be done. We're almost there. 22 is next. And I got sine cubed plus cosine cubed over sine plus cosine. Okay, the reason this one's so difficult is because you have to look at the top here and realize that's a sum of cubes. You can factor that to be sine plus cosine, sine squared minus sine cosine plus cosine squared. It's a sum of cubes, and it's over sine plus cosine. So now these cancel, and then I'm left with just this. Well, from that, I've got sine squared minus sine cosine plus cosine squared. The sine squared and cosine squared can team up and become 1. So this is really like 1 minus sine cosine, which is what they wanted. The hard part there was seeing this difference of, or the sum of cubes. Number 23 is going to be exactly like that, but with a difference of cubes. So I'm not going to waste time and do that one. It's the exact same thing. So let's just jump to 24. Somebody's probably been waiting all video long for number 23, and they're not even going to get it. All right. Cosecant 6 minus cotan 6. And that's all they give me. Okay. This is another cubes. This is a difference of cubes. So your A and your B for like in your equation would be cosecant squared x, cotan squared x. So when you do your difference of cubes, if you do it right, you should get cosecant squared minus cotan squared, cosecant 4 plus cosecant squared cotan squared plus cotan 4. That's the hard part, this jump from here to here. That's the hardest part. All right, so if you make it here, then you should probably realize that this right here is 1, using my third rule. So like I don't even need that part, it's just 1. So really I'm only focused on this other part, this cosecant 4 plus cosecant 2 cotan 2 plus cotan 4. All right, now what I'm going to do here is going to look really weird. Your cosecant 4, you can break up to be cosecant 2 cosecant 2. And same thing with this cotan 4. You can be cotan 2 cotan 2. The reason you want to think of it like that is because now you're going to come through and change cosecant squared and change one of the cotangent squared. So you'll have your cosecant squared. Then orange, you can change cosecant squared to be 1 plus cotan squared. So it's like this, 1 plus cotan squared. I have not touched the middle part, so that's still cosecant squared, cotan squared. Then over here, I've got one of them as cotan squared. And then I'm going to change cotan squared to be cosecant squared minus 1. All right. Now I'm going to distribute everything and rewrite this problem. So it's a cosecant squared It's a cosecant squared cotan squared. It's a cosecant squared cotan squared. It's another cosecant squared cotan squared. And then it's minus a cotan squared. I'll add some color for clarification. So this guy was the first orange and blue. This guy was the red middle. And then this guy was the last orange and blue. So I hope that helps clarify. Now, what you have here is you have 1, 2, 3 of these cosecant squared, cotan squared. And then everything else that's left, so this is all gone. All that's left is a cosecant squared minus a cotan squared. That's rule 3. That's 1. So this turns into 1. Then I'm at my answer. That was a really hard problem. I know it's very difficult to be able to see like this step right here, to know to change 2 of the cotans and not the other 2. I know, I get it. It's difficult. Let's just keep moving. Okay, last problem. If you made it this far, you should be real proud of yourself. Okay. I don't feel like writing all that out, so I'm just going to move this. On number 25, you're going to need to FOIL this out. So if you FOIL this out correctly, like FOIL this part and FOIL this part. So if you FOIL it out correctly, you'll get 4 sine squared plus 12 sine cosine plus 9 cosine squared. That's this first part. I'll do the other one in a different color. And if you FOIL this part out, you'll get plus 9 sine squared minus 12 sine cosine plus 4 cosine squared. Okay, well, notice that you have a plus 12 sine cosine minus 12 sine cosine. Those are going to cancel. And so all that's going to leave you with, I've got 4 sine squared and 9 sine squared. That makes 13 sine squared. And then I've got 9 cosine and 4 cosine squared. So that's going to make 13 cosine squared. So really, you can GCF a 13 out of this and just have sine squared plus cosine squared, which is rule 1. This turns into 1. 13 times 1 is 13. That's what they wanted. So, all right. I know. And this is only set B. We still have another set to do. I don't know if I'm going to make a video for that one because these take an incredible amount of time. But use these rules, kind of play around with it. You have to keep making moves. You can't freeze. But yeah, hope this video helped.